In this video, let's practice doing some gas stoichiometry equation work. Notice that G means gas, so NH3, ammonia, that's a gas. This oxygen's a gas. This nitrogen dioxide's a gas. However, L means liquid. This is an L, not a 1. And that means that this water, it's not a gas, it's not a solid, this is pure water as a liquid. It's not the same as what comes out of the faucet. What comes out of the faucet is actually a mixture of water, gases, minerals. Anyway, this is pure water. Okay, let's perform this equation. Okay, when we read it, we see that it says what volume of oxygen as a gas is required in the combustion of 78.5 grams of NH3. Notice it says what volume of water, what volume of oxygen. That means oxygen is my unknown. It's the material of the question. And since I'm wanting volume of it, we're going to want liters to be at the end. We want our answer in liters, so the end of our foldable will be open. Okay, it's starting with 78.5 grams of NH3. We always put the given over 1. But since it gives me grams of NH3, I know I'm going to need the molar mass of NH3 during this question because grams of NH3 are involved. So I'm just going to find the molar mass of that right now so that when it comes time to put in numbers, I'll already know that number. It makes the work just a little bit clearer and easier. So NH3, okay, if I look at nitrogen from the periodic table, it's 14.007. I'm not going to round our atomic masses at all, just take them straight off the periodic table. Notice nitrogen, there's only one of them. So when I find the atomic mass of 14.007, I just leave it that way. Now hydrogen is 1.008. So hydrogen at 1.008, but I have 3 of those, so multiply by 3 for the hydrogens, okay, multiplying by 3. Okay, now I can add all that together, and I happen to know that the answer will be 17.031 grams per mole of the NH3, and since I have NH3 here, it's already labeled. Okay, we will use that soon. All right, now let's begin our work. So we have given, and the grams are NH3 at the start. Here's grams of given, and just like we've always said, we don't want the units gram or NH3 in the answer of the question at the end, so we need to cancel that out. We will copy it to the bottom. So grams of NH3 has to be copied to the bottom so that it will cancel from given grams. Given molar mass of grams will go here. Molar mass of NH3 will go here. That'll make it cancel. We're converting that to moles right now. Okay, grams of given converts to moles of given here. So moles NH3. Okay, let's continue. We'll put the numbers in later. Okay, moles of NH3. We want volume of oxygen. We want moles of NH3. So that means moles of NH3 has to be copied to the bottom so that it will cancel. Okay, moles of NH3. Remember, MOL is the abbreviation for moles. Okay, we have to copy that to the bottom so that it can cancel out. The first time I have moles in the bottom, that's the mole ratio step. The first time moles is in the bottom. So mole ratio, remember, moles of given is at the bottom. We've got that, moles of NH3. But I want moles of unknown at top. Since oxygen is in the question, that means oxygen is the unknown material, which we marked here. And I want moles of oxygen at top because, again, we want moles of unknown at top. Okay, we need another step because I still don't want moles of oxygen in the answer. I want volume of oxygen. I want liters of oxygen. So I need another column. Okay, so moles of oxygen is copied to the bottom. And I want liters of oxygen. And notice, just like here, we can have liters of oxygen at the top, liters of unknown, liters oxygen. And notice every box has units and liters of oxygen, volume of oxygen. This matches the question. So now that's where the equal sign would belong, and we can start filling in the numbers. And if I just kind of go backwards from this way backwards, okay, notice liters, we're going to use 22.4. Now that says that, okay, and we'll put the 1 on the bottom, see? Now that says that 1 mole of oxygen is 22.4 liters of oxygen, which is true. Okay, then remember we have the mole ratio step. And since NH3, notice here's NH3, and here's the coefficient for NH3, it's a 4. Okay, that's where the 4 comes from. The coefficient tells us the number that goes in front of the moles of unknown, or moles of given and moles of unknown. It'll be the coefficients we use. Here's oxygen. Okay, here's oxygen. Notice oxygen has a 7 in front, and that's where the 7 is coming from. Okay, and we have a couple boxes left. Notice here it even says 1 mole, and so that's why I'm putting a 1 here. 1 mole of NH3. Okay, notice it says grams. Remember I had you find the molar mass of NH3 at the beginning? Now we get to use that. 17.031. Okay, that's how many grams of NH3 make 1 mole of NH3. Every box has a number, unit, what it is, number, unit, what it is, number, unit, what it is, all the way around. So we're ready to calculate. Let me put this in the calculator directly as I follow along with my finger. Okay, so we're going to have 78.5 times 7. There's no point into multiplying by 1. Okay, times 22.4 divided by 17.031 divided by 4. And I'm not going to divide by 1 or divide by 1 because they won't change our answer. But you could if you wanted, because it won't change the answer. You'll still get 180.6822, a whole bunch of stuff. Now, in my question, I only have 3 significant figures. So I'm only going to keep 3. 1, 2, 3. Okay, so that means 180, but look, the 0 is followed by a 6, and that makes it turn into a 1. So that's how many liters of oxygen I have in this answer. 181 liters of oxygen is my answer. And use a capital L for liters. Okay, let's do a couple other questions that are different. Okay, here I've got liters to liters. And I'm going to pretend this is just any old question using my foldable, even though I know of a couple faster ways we can do this. Okay, so it says I have 5 liters of oxygen. 5 liters of oxygen. That's what I'm starting with. Now, because I have liters, I'm starting with the foldable at the beginning opened. It's asking for liters of carbon dioxide, so liters, I leave this open at the end. Notice there's no mention of grams. So periodic table, don't need it this time. We only have liters and liters. Okay, we have liters of oxygen here at the beginning. I don't want liters of oxygen, I want liters of carbon dioxide for the answer. So liters of oxygen gets copied down here. And that's what I've written, liters of oxygen. Okay, now, notice here, liters, if it's not in moles to begin with, I'm always teaching to convert to moles right away. So liters gets converted to moles of given. This is liters of given. It gets converted to moles of given. Okay, so here's my liters of given. Now I have moles of given. But remember, moles of oxygen, I don't want moles of oxygen for my answer. I want liters of carbon dioxide. So that means that moles of oxygen has to be copied to the bottom. Moles of oxygen. And that's the same thing our foldable says. 1 mole of given. Okay, we can put the 1 now if you want. Okay, moles of given. Okay, moles of given goes onto the bottom. That's the coefficient. That's going to be where I'm going to use the mole ratio. So I'm going to go straight up and put moles of unknown at top. Moles. And remember that carbon dioxide is in my question, and that's how I know the unknown is carbon dioxide. Okay. I don't want moles of carbon dioxide for the answer. I want liters of carbon dioxide. So moles of carbon dioxide at this point right now gets converted to liters of carbon dioxide. Liters carbon dioxide. And notice right here, it does say mole of unknown gets converted to liters of unknown right here. And you'll use 22.4 liters because that's how many liters make 1 mole. So if I put a 1 down here like the foldable showed, okay, I put a 1 down here just like it showed, and I put 22.4 at the top, just like the foldable shows also, that now says 1 mole of carbon dioxide equals 22.4 liters of carbon dioxide. So, okay, we're not finished. Okay, now we're going to do the mole ratio with the coefficients. Okay, carbon dioxide, if I look that up, I see 3 on the carbon dioxide. That's where the 3 comes from. Now if I look up oxygen, notice it says 5. Just do exactly what the coefficients say. I never usually bother with reducing them, but I can if I need to. It's just it'll fit in the calculator and work the same way if your numbers are all correct. So I don't even bother reducing with my students who struggle a little bit with math. It's okay. Liters of of oxygen. We already put a 1 there because we saw earlier that that was a 1. Okay, but on the bottom, notice 22.4 liters. If it had been mass, okay, then I would have used molar mass. But this is liters. So when I start with liters, I'm going to use the 22.4 liters. So fast. 22.4. And again, I am aware that there's some reducing I could do, but I'm going to pretend I don't see it. Okay, so let's just do what the calculator says, and I'll put it in as I read it to you. So we're going to do 5 times 3 times 22.4. Come over here. Okay, I don't need to divide by 1, but I could divide by 22.4. I can divide by 5. Okay, I don't need to divide by 1. That won't change the answer at all. And notice the answer on the calculator says 3, which will really translate to 3.00 liters of carbon dioxide. Now earlier, if you saw it, I could have said, look, there's 22.4 here and 22.4 here. They cancel. And here I got 5 liters, and here I have 5 liters. They cancel. And that meant 1 times 3, which is 3 on top, divide by 1, divide by 1. I already knew my answer was 3 a while back. But that's just a different way to do it. No problem. And there's yet one more way, but I'm not going to show that. Okay, what about this one, letter D? We have 4.50 moles of water at the start. And we want to know how many liters of propane. Now C3H8 is propane, okay? Actually put it down here. C3H8, that's propane. Okay, how many liters? All right, let's do it the same way. Now this time I'm starting with moles. So that means the beginning, since I'm starting with moles, will have the foldable closed. It starts with moles. Okay, and if you start with moles, notice the very next thing you do is the mole ratio, if you use the foldable to kind of guide your thoughts. So moles of H2O goes to the bottom. And remember, that's the given. Okay, now I put the unknown on top. Propane is in my question. That's the unknown material. So C3H8 goes on top because there's my unknown material, the propane. And it's moles of propane at top because moles over moles make the mole ratio. Okay, we'll put the numbers in a little bit. Let's get the words first. I want liters of propane. If I stop right now, this would be like the very first assignment where it was moles to moles, but I don't want moles of propane. I actually need to add one more step to make it convert to liters. So I want liters of C3H8. So now I can get liters, but I also have to cancel, right here, I have to cancel moles of C3H8. Okay, so moles of C3H8 will cancel. We know that the given, which is moles of water, okay, they cancel right here. Now I just need to fill in the numbers. Okay, so just like before, if we have liters at the end, we're going to use 22.4 liters as the number at the end. And here it is. So 22.4 liters. Okay, that's the molar volume of propane or anything. Okay, and the number down here, as it shows, is a 1. So I'm putting in a 1. Okay, here I use coefficients. C3H8's on top. Notice there's no number, and no number means 1. That is not a mistake. And then H2O, I go to the equation and I see a 4. So I'm putting a 4 here at the bottom to show 4 moles of water for every 1 mole of C3H8. Okay, I have number, unit, what it is, number, unit, what it is in every box. That means we're ready to calculate. And again, I'll point to it as I do it in the calculator. So 4.50. Okay, I can skip the times 1, but I have to do times 22.4. Come to the bottom. Okay, I don't really have to divide by this 1, but I must divide by the 4. And again, I don't really have to divide by that 1 either. So I can just say equals now. And the answer is 25.2 liters of C3H8 because it's the only unit that did not cancel out. All the other units canceled out, but liters of C3H8 did not. My final answer is 25.2 liters of C3H8. To help you do any question in this unit, just look at your foldable carefully. If it's closed, it starts with moles. If it's open, you're either beginning with grams and you're going to use molar mass, or you're beginning with liters and you're going to use molar volume. At the end, if it's closed, you're ending with moles right after the mole ratio. You're ending with moles right there. But if you open it, if you use molar mass, your answer will be in grams. If you use the molar volume of 22.4, that will make your answer be in liters instead. So just open it to the positions that you need, focus on the things you want, and read what it tells you to do. Sometimes it tells you ones, sometimes it tells you to look at the coefficients, sometimes it tells you to use 22.4, sometimes you have to get out your periodic table and find the molar mass. Just do whatever the foldable tells you to, and read your periodic table carefully. Okay, use your notes. Please ask questions if you need further help.